Good day, folks. This is video number 17 for a playlist that's devoted to motion design analysis in 3D Experience, release 2025x. Now, I would like to say a few words about the use of the initial condition icon in the motion design when joints are used for that purpose. I have already prepared some videos where markers are explained in the context of how to specify initial conditions, but this is the only one that I'm discussing the joints. We'll come to that in a minute. Now, within motion design, when you have for example, a dynamics scenario, a dynamics, rigid body dynamics problem, you can specify initial conditions, both velocity and position, and then you can display that on the screen by using the initial state solve icon. I will do this in the context of a very simple problem, a prismatic joint. Obviously, I need a joint in order to talk about this video. It's going to be a prismatic joint, a block that is traveling along that track as a prismatic joint. Now, it can be done for other joints too, but at this point, number 17, video 17, is devoted to this particular problem. Now, I've got to be careful because there are some issues that are going to arise that need to be explained, but we'll see that. So the problem that I'm going to be doing is a block and a track. And I use this particular coordinate system in case you want to follow me, and the dimensions are given here. And on purpose, I make that block so that before the joint is created, is actually off the track, 50 centimeter up, 50 centimeter to the right. And so the prismatic joint is going to be made out of the edge of the block and the edge of the track. And as soon as you do that, actually the block transfers down and places on the track, okay? But it vertically comes down, so distance from this corner point all the way to the end is still 50 centimeter. And then you need two faces, so I'll select these two faces for prismatic joint. Here is the setup one more time. This is how it's going to look like if you look at the side. And the ribbon for the motion design, as soon as you go from assembly design to motion design, this ribbon will appear, and here is the initial condition. And this is the initial state solve. You can see that. And as soon as you go into motion design, a dynamic scenario is created. Notice that this is picked by default. The default duration is 5 seconds. That's fine. Just leave it at 5 seconds. It doesn't matter. And if you click on the initial condition icon, you have two choices, marker or joint. So I'm going to be selecting joint here. And then it says, where is your joint? Of course, in my case, there's only a prismatic joint that I can select from the tree. And for initial condition, you have several options. None is basically just sits there and no initial velocity. You can specify position, or you can specify velocity, or you can specify both. So I'm going to do both actually. When you click, when you select this position and velocity, you get the default value 0, 0. I'm going to change that to 100 centimeter and for the position. And this is the big question: 100 centimeter from where? That's the issue that I run into in this particular tutorial. And the velocity of 10 centimeter per second. Okay. Now, when you plug in these and say okay, the block stays where it was. It's not going to move. If you want to see it actually moved, then make sure you do an initial state solve so it goes to the new position. Okay, you don't have to do that, because if you run the analysis case without even moving it to that location, automatically it's going to be moved there. Initial condition is going to be taken into consideration. Okay, now of course, once you run it, the question is, as I said, where is this 100 centimeter measured from? Now, it may be reasonable to assume that it is measured from where it was before it was actually moved, that 50 centimeter away from the left side. Okay, if you go that route and say that this uh, may be measuring from the location where it was sitting there, 50 centimeter to the right, there's going to be a discrepancy between how the video is created, video tutorials, video animation is created. If you go with this route, which makes sense, it just doesn't add up. We'll see that. We'll see that. Okay. Uh, so what it does actually is if you say 100 centimeters, just like in the previous dialog box, what it does, it adds 100 to that and it moves it to location 150 centimeter. And then it starts moving back, moving to the right based on the velocity that's given it. And this is why it's not, in my opinion, properly documented and it's not really very appealing. Okay, this is what I meant. You don't have to move it by initial state solve. You can just run it and it's going to work, no problem. And you can see what's going to happen. If I use that interpretation, when I plot the position of the block, it should not be 100. It should be 150, and it's not. It's going to be 100. Okay, that's the whole purpose of this video tutorial. All right, let's start with assembly design. We're going to make the part a very simple part, just two boxes basically. Okay, I'm going to insert my first part, and this is going to call a track. Properties. I'm going to call this thing track and track, and let me make it yellow. Okay, let me go make it. Double click on part design. I've already changed my units so that they're centimeters. So on that vertical plane, I will sketch. Okay, the rectangle. Notice that X is going to the left, global X is going to the left, Y is coming towards you. So let's dimension these things. So this is going to be 20 centimeter. And the edge on the side is going to be 2 centimeter. Exit. And then we pad it by 200 so that we get the track. Okay, there we are. Okay, good. So notice that Y is going to the right, X is coming towards you, and Z is going up. So now we're going to go all the way to the top, insert, another 3D part. I'm going to call this thing track, sorry, block, block, block. Let me change the color to orange. And we're going to go make it. Double click. On that vertical plane, on the YZ plane, I will sketch. Okay. So let me sketch my rectangle here, dimension it. This is going to be 10 centimeters. This vertical height is going to be also 10 centimeters. The dimension from here to here is going to be 50. And the dimension from here to there is also going to be 50. Okay, so there is the block on the top, exit, and then pad it by 10 centimeters. So what we have here, what you see there is actually this slide, okay? These are the dimensions that are used, and it's this slide. Okay, now we're going to create our joint all the way to the top. We're going to create our joint. First thing we're going to do, we have to go to the assembly to create not the joints, but the constraint. Joints are going to be created later on. So fix, you're going to fix the track. There we are, track is fixed, you can see that. And then we're going to do a prismatic joint. Okay, I will use this template, edge, edge, plane, plane. So turn around this edge, and that edge automatically brings it down and places it vertically down, which is going to be 50 centimeters to the other side. So this plane and that plane, okay? And I don't need this last set of selections. Say delete and okay. And don't worry about contact. So here's the situation. So notice that we have created a fixed joint and a prismatic joint. I mean, I always like to update these things. It's okay. So now what we're going to do is we're going to go to motion design. Motion design. As soon as you do that, it says, okay, here's the name of the mechanism. Is this good? Say okay. And notice that automatically the joints are created. Prismatic joint. And what I showed you were not joints, they were an engineering connection. Now they're turned into joints. Okay. So if you go to mechanism here, by the way, look at what happened. The distance from there to that corner is 50 centimeters. Okay, just keep that in mind. And the whole thing is 200 centimeters. Okay, so now go to mechanism tab, and under initial condition. So what I'm showing you now is this particular slide. Uh, Before I do that, notice that the mechanism has been created here. If you double click on this dynamic step, it says it's dynamic step, default 5 second, etc. The slide that I showed you. Now we go to this tab on the initial conditions. We don't want marker, we want joint. And it says, where is your joint? Well, the joint is that prismatic joint, and we want position and velocity, and position is 100, and velocity is 10 centimeters per second. So this slide that you see here is actually that slide, okay? All right, and then we say, okay, notice that nothing happened here. I mean, basically I have my initial condition there, no problem, right there. On that joint, 100 centimeter and 10 centimeter per second. Now, if you want to see it move to that location, you're going to go do a initial solve state. But look at what happens when I do that. It actually didn't go to 100 centimeter. It went to 150 centimeters. You can see that. Okay, good. Didn't have to actually do this. I could have just gone there to simulation and ran it. But I'm going to do it now. So you click on it, wait until it finishes. It finished. Okay, run analysis case, finished. Let's check. First of all, a couple of things. If you results have been created, if I select dynamic step here, I have to select this. I go to result and I go to play animation. Look at where we are. This is 50, this is 100, and then 10 centimeter per second times 5 seconds is going to give you to 200 right there. Okay, you animate it. So it starts at 150 and it goes there. That is not the issue. The issue is when I go and do a 2D plot, show me the position of the block, the Y position of the block. It doesn't start at 150. It starts at 100. So one of these interpretations is not right. I mean, uh, the behavior is okay, but then animation shows that it starts at 150. So in principle, in my opinion, that should be 150 to 200, and it is not. I don't know whether it's a bug or it's the assumption that I made that it makes sense to say that 100 centimeter is from where it was before. One of these is not actually consistent with the other one. All right, folks, so that's pretty much it. Incidentally, if you look at the block, no problem, but you can also do the prismatic and then say, show me the plot translation. It ends up right there. So exactly on the same curve. So either one. It's not consistent with that animation plot. All right, folks, good luck.